Alright, hello 20-1 students. So today we are looking at lesson 2.2. So this is an extension of the previous lesson. So we covered the trig ratios of any angle already a little bit. So just a quick recall because we're going to be using some of these same ideas today. So if you remember when we covered our last lesson, we developed this. So this is the table we developed, right? And it helped us to understand something called the cast rule, which helps us to identify where the different trig ratios are going to be positive or negative, okay? So in the previous lesson, we looked at solving for angles or exact ratios based on given a point on a graph. We also looked at if you're given an angle. And then we also looked at when you're given a ratio. And so today we're going to extend on that a little bit because we didn't use a whole lot of the idea of special triangles, so the ratios that we have for special triangles in our lesson last time. And this time we're going to be working a little bit more with some of those ideas. So we're going to take what we did in the first lesson and we're going to extend it to basically solving when we're given like sign of a decimal. So we didn't look at that at all last time. And we're also going to be looking at some of the ratios that should be familiar to you if you've memorized those special triangles that we've talked about. Okay, so that's kind of where we're going today. So to start out with, we're just going to do a little example to kind of think about how these trig ratios are going to be in something called a quadrantal angle. And so basically, if you think about it, remember we talked about how we have quadrant 1, 2, 3, and 4. And so you see this word quadrant in this terminology of a quadrantal angle. So what a quadrantal angle is talking about is basically just an angle that's in standard position, and it's where your initial arm is going to be on, your positive x-axis, so because it's still in standard position, right? And then your terminal arm is going to be on one of the four lines that divide the quadrant. So it's either going to be also on the positive x-axis, or it's going to be on 90, your terminal arm, 180, 270, or 270. Okay, we don't go back to 360 because that's what 0 is, right? So yeah, let's walk through and we just kind of want to think about basically what are going to be our different values for sine, cosine, and tan for these different quadrantal angles. And so if you look here, you can actually see that they tell you what your values are in this position for x and y, given as an ordered pair, and then they give you your value for r, okay, which is equal to x, okay, in this particular case. And so then you can use that to think about your trig ratios here. So sine theta is equal to y, which for 0 degrees, y is 0, divided by r, and r is equal to x, but in this case we can just say r because it's not going to change if you have 0 divided by whether we call it r or x. It's still going to be 0 divided by anything is 0, right? Cosine theta is going to be x over r, so x we don't have a number value for, but we know that r is equal to x. So in this case, we are going to substitute in that x value, because if we leave it as x over r, it's just two variables that we can't simplify. But because we know that r is equal to x divided by x, what is anything divided by itself? It's 1. Okay, so we can probably start to see there's like a little bit of an emerging pattern here of pretty simple numbers, right? We're not seeing any complex decimals or anything for these quadrantal angles so far. If we go to tan theta, we have y over x. So in this case, y is 0. And we'll just leave x as x, of course, and so we end up with 0. So pretty straightforward sine, cosine, and tan values for the 0 degree quadrantal angle. Let's try 90 degrees. So with 90 degrees, let's do that one in orange maybe. Okay, so this one's our 90 degree. And so if we look at what we have going on with our values there, we have in our ordered pair, x is 0, and then y is just an undefined value of y, but r is going to be equal to y. Okay, so because r is always like our terminal arm, right? So in this case, r was equal to x because our terminal arm was laying on the x-axis. In this case, r is going to be equal to y because r is on the y-axis, positive y-axis. So now, for sine theta, we have y over r. So y is y. R is equal to y. So essentially what we're doing is y divided by y, which is going to be equal to 1. Okay. For cosine theta, we have x over r. In this case, x is 0 divided by r. 0 divided by anything is 0. And then in the last one, we have tan, which is y over x, which is 0. And what happens when you divide anything by 0 is you get the term undefined in your calculator because you can't divide things by 0. Okay. What else is there? Let's move over to 180 degrees. I'm just going to grab a different color here a second. So 180. It's over here. So this is the one we're doing here. Okay, so with sine theta, we have y over r. In the 180 degree quadrantal angle, y is equal to 0 again, right? Because we're looking at an angle that's flat on the x-axis. So y is going to be 0 divided by r. R is equal to x. So because this isn't helping it, like setting it equal to x isn't really changing anything, we'll leave it as r, and 0 divided by anything is 0. Cosine is x, which in this case, because we're over here in this quadrant, we're going to have a negative x value divided by r, which is equal to positive x. So if we have negative x divided by positive x, we end up with negative 1, right? Anything negative divided by its positive version is going to be a negative 1. And then last of all, we have tan theta, which is y, which is 0, over x, which is negative x. But even if it's negative, we still end up with 0 as our answer. Okay. Last of all, 270. Find one last color here. Okay, so 270 is for sine theta. So now we're down in this negative y quadrant. So sine theta is going to be negative y divided by r, which is equal to y. So again, we're going to see negative y over y, which gives us negative 1. For cosine theta, we have x over r. X in this case is 0. Divided by r is going to be 0. And then last one is going to be tan theta, which is going to be y over x. So our y is going to be negative y, and our x is 0. So again, we have that undefined angle there. So just before we move on, I just wanted to quickly go over what the undefined, because I think for a lot of students that seems like a little bit of a abstract concept. So I want you guys to understand what that's actually telling us. So with, for example, the 90 degree value that's undefined, we have our y value over our x value, right? Given that we have theta at some value. Now for tan theta, when its theta is 90 degrees, if this value here becomes 90 degrees, we end up with, so we still have our y and our x values, but now all of a sudden theta here is 90 degrees. And so our line is going to have to go up like this in order to make that angle. And so we cannot complete the triangle according to geometry, right? This is just going to become a square. And so that's why we represent the tan of 90 degrees as being undefined, okay? Because that value for tan is never going to allow a triangle to be formed. Okay, so that's where we get that undefined value from. Okay, so the next thing we're going to look at is strategies for solving angles given their sine, cosine, or tangent. Okay, so we're given the value, the trig value, and we need to solve for the angle. So some of the basic steps, and there might be a little bit of variation on this, but the first thing you should be doing is always determining which quadrants the solutions will be in by looking at the signs. So use the cast rule here. Then you can solve for the reference angle, and we can do this in a few different ways. So we can look at the inverse of a ratio if we're given that, or we can look at using a special triangle. And actually I find that this one here, using the inverse function of the positive ratio, is a little bit, I don't know, vague, but we'll see. I'll show you guys what we mean with these types of questions here. Sketch the reference angle in the appropriate quadrants and use the diagram to determine angle theta in standard position. Okay, often this is going to have two possible solutions due to the fact that there's usually more than one quadrant where the angle can fall into based on the cast rule. So if we look at example 6, it says to solve for theta, given that sine theta is equal to 0.5. So the first thing we want to do is figure out where could this angle fall into, because it says here that it's between 0 and 360, which doesn't help us out a lot. So step number 1, thinking about cast, right? So remember it's C-A-S-T. So this means cosine is positive in this quadrant, and what we're looking for is 0.5 is positive for a sine. So we want to find the quadrants where sine is positive. So in quadrant 1, all trig functions are positive, so it's going to be able to fall in quadrant 1, and in quadrant 2 sine is positive. So basically quadrant 1 and 2 have these positive values, so that's where we're going to be able to draw our angle. And I kind of sketched that in already so you guys don't have to watch me draw it out. So then the next thing we want to do is figure out, like for me personally at this point, I would think, if I know that this is 0.5, as a fraction, that's a half. So I need to think back to those special triangles that I should have had memorized. I'll kind of remind you guys of that here a second. So this is where, like at the beginning of a test, for example, I might make my triangle so I have these functions available to me if I didn't already have them memorized. So if I have a 45-degree angle, I have 1 over root 2, so that's not going to work. But if I have sine 60, it's root 3 over 2, so that's not going to work. But sine 30 is equal to a half. So basically what this is telling me is if I have sine theta equals a half, then theta has to be equal to 30 degrees. Okay, kind of try and keep that ready for us. So I can say sine of 30 degrees is equal to 1/2. And so now that I know that, basically all I need to do is apply my cast rule. So essentially that would mean my first angle would be just sine of 30 here. Remember with this, we're always using a reference angle. So our angle in standard position here would be in quadrant 1 for the first 30-degree angle. We said we could also have it in quadrant 2. So remember that means that in quadrant 2 we're going to have a reference angle of 30 degrees. So now we could say sine of, or sorry, not sine of, I wanted to put in theta there. I'm wondering if I'm using this. I'm left-handed, and so sometimes these, what do you call it? Sometimes these whiteout things I have to think about for a second before I use them. Okay, so the first one is going to be theta could be equal to 30 degrees. But the second one, I have to think about what this angle is in standard position, because I don't want to use my second reference angle, right? So in order to solve for this angle in standard position, I know that this is my reference. So to solve in quadrant 2, I would say 180 degrees minus 30 degrees gives me 150 degrees. So my two possible angles for theta are 30 degrees in quadrant 1 or 150 degrees in quadrant 2. Okay. So basically, always you're checking to see which two quadrants it is in. Then you want to solve for theta to see what the angle is going to be, and then that theta has to be your reference angle in both quadrants that you're working with if you have two quadrants. So our reference angle is the same as our standard angle in quadrant 1, so we can keep that. But in quadrant 2, we have to solve for the standard angle based on our reference angle of 30 degrees. Okay. All right, let's have a look at another example here. So solve sine theta is equal to negative 1 over root 2. So in this case, they're giving us an exact value, and we want to solve for it. So the first thing we can say is we know that our value is negative. So again, first step, use the cast rule, CAST. So in which quadrants is sine negative? Well, we know that it's positive when all are positive, and in quadrant 2, sine is positive. So then the 2 where it would be negative is the one where only tan is positive and only cosine is positive. So we know we're going to have our angles in quadrant 3 and 4. Then the next thing is, when you see this exact value, it hopefully will kind of trigger a reminder in you to think about your special triangles. And so our first special triangle, sine 45, is 1 over root 2. Okay, and so I can go in and know sine 45 degrees is going to be equal to 1 over root 2. And then because we're dealing with a negative, that was accounted for when we looked at the cast rule, okay? So even though we're given a positive with this triangle, we can still use it, but just recognize that the negative just changes the quadrants it's in, not the actual reference angle. Okay, so now that we know that, we need to keep in mind that the 45, just like in the previous example, 45 is our reference angle. So if we're in quadrant 3 and our reference angle is 45, remember that has to be between the closest x-axis and our terminal arm. So basically that means this angle here is going to be 45 degrees. And so if we want to solve for what the standard angle is, which is what we're always looking for, then it's going to be 180 plus that 45 degrees. So 180 degrees, so this is for quadrant 3. 180 degrees plus 45 degrees gives us 225 degrees. And then for quadrant 4, we need to do the same thing. So in this case, our reference x-axis is going to be the 360 degrees. And we're going to back that off by 45 degrees. So that means we're going to do 360 minus 45, which will give us 315. And so then we could say theta is equal to 225 or 315. Okay, so we've used the cast rule to determine the quadrants. Then we've used our special triangles in this case to solve for what the possible theta value would be. And then remember that that value is your reference angle, so you have to determine the standard angle, and that's our last step. Okay, so if you want, you can pause the video here a second because you have a chance to try this on your own. So solving for tan theta equals negative 1. Okay, so try and follow those same steps, and the answer is given down there for you to double check. Okay, last question, example number 8. So in this case, remember in the first question we were given a decimal as well, but it was like a nice kind of tidy decimal, so that made it easier to recognize maybe. But in this one we're given cosine theta equals negative 0. 0.6753, which might seem a little bit intimidating, but we're not going to let it do that to us. So the first step is just follow your steps and you'll be okay. So use the cast rule. So if we have a negative value for cosine, we know that it can't be quadrant 1 because all are positive there. In quadrant 2, only sine is positive, so cosine would be negative there. And in quadrant 4, cosine is positive, so in quadrant 3, only tan is positive, so that would be the appropriate place to find that. Okay, so this is where we're going to find our angles. Now the next step is we are going to break out our calculators for a question like this. So basically we're going to go, if cosine is negative 0.6753, we just want to know what theta is. So remember, that means you have to do the inverse of cosine of this value to find theta. So we're going to go second function, oops, so I hit the wrong button, negative 0.6753, close off the bracket, and we end up with 132.5. Okay, now it tells us to round it to the nearest tenth of a degree. So we're going to check and see 132.5 is in quadrant 2, so that's going to be one of our standard angles. So we can go right ahead and actually just round that one off there. So basically we did cosine minus 1 of negative 0.6753 equals 132.5 degrees. Okay, so that's going to be our first value for theta. So essentially that means going from here to there, we have 132.5 degrees. Now, what we want to determine in order to solve for what theta would be in this quadrant is we need to know our reference angle. Okay, so basically if our first angle went to 132.5, the angle that would be remaining in here would be, so if theta equals 132.5, theta r is going to be equal to 180, right, our closest x-axis, minus the standard angle, 132.5. And that's going to give us 47.5. Now, I know I always tell you guys not to round, but if we've already solved for one angle and we've rounded it to the nearest tenth, I mean, we're going to have to round, right, so that our answers kind of stay consistent. So now you can keep this 47.5 here. And if we have 47.5 here, that means that we're going to have 47.5 here, right? 47.5. Okay, and so in order to determine the angle in standard position, remember it's going to go all the way around like this. So basically we're going to have 180 plus that 47.5. So theta is going to be equal to 180 plus 47.5, which is going to give us 227.5. Okay, so now we can say theta is equal to either 132.5 degrees or 227.5. Okay, yeah, so that's solving for kind of like a decimal like that, where we don't have an exact value. Then you can kind of break out your calculator and use that. Now, technically, some of you guys will have probably figured out that you could have done that for like this as well, right? Like you could put in sine of a half. But the thing is like I'm going to want to see in some of your questions that you know that this is a component of a special triangle. So it's okay if you can use that as a backup, but make sure you still know your special triangles, because there will be questions that will be asked where you'll have to be able to identify that rather than just being able to use your calculator. Okay, so you guys have a question to try on your own where you're given sine theta of a decimal. So use the same set of steps and try that out. You're given your answers down here, and then you can go ahead and work through some practice problems, as well as be sure to have a look over the review of key ideas that's on page 95. This will help to summarize some of the things that we learned over the last 2 days for section 2.2. Okay, and that can be a good study tool. So next time we're going to be looking at lesson 2.3. So this is again going to be broken up into 2 days, and it's where we'll be looking at the sine law. So I will see you for that lesson.